Hello, welcome. We are together with one good question. Let's see what you said from us in the question. For every n element integer of 30, n to the fifth minus n, says you can divide, and he asked us to prove it. Now I think a little bit about what I can do. The first number that comes to mind is 30. Let's think about the factors. I can write the number 30 as 2 times 3 times 5. Then what should I think? N to the fifth minus n, 2 divided. It has to be divided into 3 and 5 exactly. Now this is n to the fifth minus n expression. Let's see how I can write separately. If we algebraically factor this expression, of course I did this before so that the video wouldn't last. You can give this video a like now. For example, I would multiply it in n minus 1 brackets and n times n plus 1 times n squared plus 1. Now where is the part we need to pay attention to here? What came before us, that part? See what we can say for this part, n minus 1, and when we see an algebraic pattern in the form of n and n plus 1, aren't there 3 consecutive numbers? We understand that these expressions are 3 consecutive numbers, increasing one by one. We definitely know what it's divided into. What exactly is any one of them? Is an even number example, 1, 2, 3. For example, a number like 2, 3, 4 is definitely even. Can I say the expression n to the 5 minus n? I can definitely say it's divided in 2. Later, because these are 3 consecutive numbers, I can say it's divided into 3. Then I need to examine who will be the rule of division. I need to examine whether it divides by 5. Now I have this expression. How can I tell if divided by 5? Let's see him. Let's start now. We need to do some algebraic processing. n minus 1 after n. If any of the n plus 1 numbers is divided by 5, the proof will come out clearly and clearly. Let's admit that none of these numbers should be divided by 5. So we think none of them is divided by 5. In this case, we should think of different expressions from the numbers given to us. Let's focus on the next numbers. Let's continue this way as they are consecutive numbers, n plus 2 and n plus 3. Let's assume that these numbers are divided by 5. Now if I accept that they are divided by 5, if I start with this first, so what do I mean? n plus 2, the number I said. Divide fully by 5. What will happen in this case? According to mod 5, the remainder must be 0. Right then, what can I say? I would say that n plus 2 is a multiple of 5. Of course here, k will be an integer. If we arrange a little more, I can say that n is 5k plus 2. This must be minus. Now what can I do next? If I continue a little more, what will come when I square this expression? 5 times in the bracket. 5 times k squared minus 4 times k. Plus 4 will come. Now let's examine the thick part of this with 5. What happens in this case? This expression is equal to n squared. See here, this number is divided into 5 because it is a multiple of 5. What will be the rest of us? Then our 4. This will give the rest minus 1, according to mod 5. We can continue from here. Now minus 1 gave the rest. If we edit this a little more, actually if I throw this friend across, the expression n squared plus 1, what did I find? I found that the rest is 0 compared to mod 5. So what can I say? The expression we call n squared plus 1 is absolutely 5 are fully divided. Okay, now who did we examine this for? N plus 2 number. Similarly, these operations. Let's try to apply the expression n plus 3. So what do I mean? The remainder of n plus 3 with 5. I think it's 0 and I need to prove it. What can I say in this case, friend? What I call n plus 3 is definitely a multiple of 5. The number we call m here will be one integer again. If I continue a little more, you have to show them like this in the exam. The number we call expression n. If you look carefully, 5 times m minus 3. If I squared this expression, it's 5 times in brackets. 5 times m squared minus 6 times m. We closed the parenthesis, we found the plus 4 expression. Now, if you pay attention again, This statement will definitely be a multiple of the number 5. But what about the rest of us here? So the remainder of this number will be 4 divided by 5. Then what can I say? N squared is equivalent to 5 divided by 4 numbers. Who is this equal to -1? It's been mod 5. Yes, now, if we send this -1 to the other side, the expression we call n squared plus 1, mod by 5, which will give the rest. Again, 0 will give the rest. So now your problem, when we move to a general solution, when we prove, with every n-element integer, what can I say?
How would you rate this question out of 10? Could you like the video to make me happy? Thank you.
Divides n to the 5 minus n expression. We are finishing our proof here, I ask you. Perfect question came out in the Olympics. What did this question ask, my friend? If you pay attention, he wants proof. One of the questions at the Olympics. If you want similar videos to come, please don't forget to like and follow. Point you do not understand or one different method. Also, for those who I'm waiting in the comments, I ask you to like, share, and subscribe, please. See you, bye-bye.